Now let's get into this cluster of galaxies, the Hercules Corona Borealis Great Wall. It's 10 billion light years across. Astronomers were able to determine the size of the structure by mapping gamma-ray bursts from the group of galaxies. And the overdensity of this thing lies at the second, third, and fourth galactic quadrants, NQ2, NQ3, and NQ4 of the sky, and it lies in the northern hemisphere, centered on the border of the constellations Draco and Hercules. And they measure the HCBGW by how many gamma-ray bursts are concentrated, and it seems to have around 19 GRBs with the redshift ranges between 1.6 and 2.1. And this structure contains billions and billions of galaxies. And this structure came into existence around 4 billion years after the Big Bang. So not only is it ginormous, it's also ancient. We can learn a lot from observing this massive Hercules Corona Borealis Great Wall. So what are gamma-ray bursts? They're extremely energetic explosions that have been observed in distant galaxies, and they're the brightest electromagnetic events known to occur in the universe. Bursts can last from 10 milliseconds to several hours, and after an initial flash of gamma rays, a longer-lived afterglow is usually emitted at longer wavelengths: X-ray, ultraviolet, optical, infrared, microwave, and radio. And the radiation of most observed GRBs is thought to be released during a supernova or superluminous supernova as a high-mass star implodes to form a neutron star or a black hole. And a typical gamma-ray burst releases as much energy in a few seconds as the sun will in its entire 10 billion year lifetime. And between the years of 1997 and 2012, astronomers mapped these bursts in the sky with the help of the robotic satellites Swift and Fermi, which looks for gamma-ray bursts and measures the redshifts. In the map they produced, they noticed something interesting. 14 gamma-ray bursts have very similar redshifts and are very close to each other. That means that there's a very large group of galaxies and matter in the region. And they say for measuring these bursts, it comes up with a very large structure, 10 billion light years in diameter.